Okay, so today we're in section 4.5. We're learning our third method of graphing a linear equation. Okay, and that's graphing linear equations in something we call standard form. Okay, so standard form is this, and I think I forgot to put blanks in here, so you can just underline it or highlight it. AX plus BY equals C. What does this mean? A number, and it's going to change. A number will represent A. It could be 2x. It could be 3x. Plus some number in Y, so it could be 3x plus 4y. All right, let me give you an example of what an equation could look like. 3x plus 4y equals 12. So here's what standard form means. Guys, this is so important, okay? That my x and my y term are on the left side of the equation, which makes, I think you would agree with this, getting it in slope-intercept form or getting it what we call ready to graph, that would take us some time, wouldn't it, to get it in slope-intercept? To get y solved for it, that would take us some time. So there's another way to actually graph. When an equation is written this way, there's a faster way to graph it than getting it all the way to slope-intercept. Okay? I can just leave it right how it is. I can leave it in that format and use a different method. So now I'm going a different route to still graph it. Okay? So when is this method practical? It's when my equation is in standard form. All right? So let's look at our first equation. All right? And again, wouldn't y'all agree that getting this in slope-intercept would take some time? You absolutely could do it and graph it. It'll look the exact same. However, it's going to take some time. So I can use a method called my XY-intercept method. All right? Here's the first starting point. You need to write the equation a second time. Negative 2x plus 3y equals negative 6. Okay? Say, why did I write it twice? Here's why. On the first equation, you're going to solve for the x-intercept. You need to write that down. On the second equation, you're going to solve for the y-intercept. And you're going to write that down. X-intercept and y-intercept. Okay? Give you a second to finish that. So my rule is pretty simple. When I need to solve for x to get the x-intercept, my rule says that I plug in 0 for y. So negative 2x plus 3 times 0 equals negative 6. Does everybody agree that anything times 0 is 0? So what we're trying to do is cancel out one of our variables. Okay? When I plug in 0 for y, now that one's eliminated, and I can solve for x. What would I need to divide by on that first one to solve for x? Just tell me. Negative 2. Okay? I can tell you guys are paying attention. I appreciate it. Now, what's negative 6 divided by negative 2?
3.
Positive 3. X equals positive 3. Now I must put this into an ordered pair. When my x value is 3, what did I plug in for y?
0.
Put that into an ordered pair. 3, 0. When I plugged in 0 for y, my x value was 3. That's my first point. Okay? Now I'm going to do the exact same thing for y. When I solve for y, I plug in 0 for x. When I solve for y, I plug in 0 for x. So now, negative 2 times 0 plus 3y equals negative 6. Now this cancels out completely. So now what could I do to solve for y?
Divide by 3.
Divide by 3. The division will most of the time be you're close, will be very simple division. Y equals negative 2. Okay? So remember to plug it in the right place in your ordered pair.
2, 0.
No. What did you plug in for x? What did you plug in for x?
3.
0. okay? You plugged in 0 for x, and you got a y value of -2. 0, -2. Y is -2, so that has to go in the y value in the ordered pair. So now you can come over to your graph, 3, 0, 0, -2, and draw your line. Okay, and you're done.
So just
Okay. All right, we're going to do several of these. The good news about today's lesson is it's literally this repetition of the same concept. Okay, so remember, my first equation is my x-intercept. You will not have two equations written. You have to know that you're going to write it again. -2/3 x plus y equals 4. Okay? You need to write a 4 instead of a 0. Okay? So I've already changed it on the notes for next time, but I need you to change that 0 to a 4. All right? Now, on the second one, remember this is the y-intercept. Okay? This is the y-intercept. All right, so now in order to solve for x, what do I plug in for y?
0.
0. So -2/3 x plus 0 equals 4. So now, is that 0 even relevant at all? No, it's just nothing. You can like literally just cross it out. How would I get rid of a fraction connected to a variable? Micah? Reciprocal. Times it by -3/2. Whatever I do to one side, -3/2. Okay? And a real nice thing is about to happen. Can I cross reduce right here?
Yes.
Yep, and my denominator's gone. X equals, so here I thought I was going to have a fraction, and now I don't. X equals -6. Can you put that into an ordered pair now?
Yes.
What would the ordered pair be, Nick?
-6 of 0.
-6, 0. Because I plugged in a value of 0 for y, and my answer was -6 for x. All right? Now, y is going to be really nice. Look at y.
Divide by 1.
Anything divided by 1 is just the other number. What happens when you plug in 0 for x?
It crosses out.
That cancels out completely, right? -2/3 times 0. Okay, so now y equals 4. There's literally no work to do. There's no work to do. When I plugged in 0 for x, that was gone, and all I have is 1y equals 4, but if I divide by 1, it's just going to be 4. Okay? Can I put that into an ordered pair? What would my ordered pair be?
0, 4.
It would be 0, 4, because I plugged in 0 for x. All right, go ahead and plot those 2 points on your graph. Okay, point number 1, -6, 0. Point number 2, 0 up 4. And draw my line. All right, who got that? Anybody get that? Raise your hand. Raise your hand. Who got it? Okay. All right, what did you mess up on? Okay. All right, yeah. So just watch out for that. You got to watch out for those negatives. Guys, another helpful thing you could maybe look at, x equals -6. So go to a -6 on x. Okay? Y equals 4, so go up to a +4 on y and plot your point. Okay? That might help.
So the ordered pair is the answer?
The ordered pair tells you where the point goes. The answer is the graph.
Oh.
The answer is the graph. Okay? All right, let's do another one. Let's do another one. So on the first one, it's our x-intercept. Wait a second, how am I going to find my y-intercept? There's nothing there.
You rewrite it.
You got to write it again. Okay? So for the y-intercept, write it again. X plus 3y equals -3. All right? I need you to go ahead and solve for x and solve for y. Okay, so to solve for x, what do I plug in for y? 0. So it's x plus 3 times 0 equals -3. Well, what's 3 times 0? 0. So x equals -3. There's nothing else to do. Now, if there was a number connected to x, I would divide. So it's -3, 0. Who got that for the first one, for x? Raise your hand if you got that for x. Now for y, to solve for y, what do I plug in for x?
0.
Plus 3y equals -3. So now this is gone. What do I need to do to solve for y? What do I do?
Divide by 3. And then
Divide by 3 on both sides, guys. This is not 0. What's -3 divided by 3?
1.
Nope.
negative 1.
-1. So what's my ordered pair? 0, -1. I plugged in 0 and I got a -1. All right, now get it on the graph. Plot a -3 on x and a -1 on y, and you draw your line. Okay, does your graph look like that? Raise your hand if your graph looks like that. Okay. All right. We're going to skip this last one because it's literally just the exact same thing again. Okay. Now, we're going to go back to the basics. Don't let your mind play tricks on you. Solve for y. Okay, this is not plug in 0 for x. This is way back to the basics. I want to get this formula in y-intercept. Y equals mx plus b. Okay, where y is solved for. I need you to go ahead and do that. All right, so this is something that I'm not teaching you anything new here. This is back to the basics, getting it in slope-intercept. Okay, so Mason subtracted 4x first from both sides. Mason, can you subtract those and say 20x?
No.
No, you cannot subtract. So now 3y equals -4x plus 24. Okay? Now, guys, what do I do across the whole equation?
Divide by 3.
Divide by 3. Now, my slope stays a fraction. It stays rise over run. Y equals -4/3 x plus 12. Okay? Now, here's why we bring this up. At this point, it is not practical to do x equals and y equals, what we've been doing in this lesson. At this point, when an equation is in slope-intercept, I can literally, oh, sorry, that's not a 12.
It's plus 8.
That's an 8. I saw Josh give me a weird look, so I knew I did something wrong. Okay, now look. At this point, I can just look at this equation, and I know where my first point goes. Where's the first point going to go on this equation?
Over left 4 and down.
No, not yet.
Oh.
Up to an 8. Remember, the last number in the equation is my y-intercept. So I go up to an 8. Now, where do I go from there?
Down 4.
Down 4.
Right 3.
Right 3, plot my point, draw my line, and I'm done. So when an equation is in slope-intercept, I use my slope and y-intercept. But when it's in the ax plus by equals c, just use your x and y intercepts like we learned today. Okay? So it depends on how much work it takes you to get this in slope-intercept. We could go back to the beginning of the lesson and write every single one of those equations in slope-intercept and graph them, and guess what? It would look like the exact same line. The exact same line. It's just a different way of doing it. Okay? Is that kind of pulling together in your mind? Do you understand that? I literally could go back to the beginning of the lesson and use XY tables. Anybody miss that method?
No.
You're like, man, I didn't get to do the XY table. You could. Oh, fractions would be fun. Okay? All right, one more example. Okay? Has maybe a parent or a coach ever told you it's all or nothing? Has anybody ever told you that? Yeah. It's either you're going to get everything or you're going to get nothing. Okay, now a word problem that deals with x and y intercepts is an all or nothing scenario. Okay, but you have to understand now you're giving a category to x and y. So I'm going to read it to you. I want you to think while I'm reading this, what category stands for x and which category stands for y. Okay, because the interpretation is everything. All right, and this is definitely on your quiz and test. You have $6 to spend on apples and bananas. The equation 1.5 plus 0.6y equals 6 represents the situation where x is the number of pounds of apples and y is the number of pounds of bananas. Use intercepts to interpret the equation. What does x stand for? X stands for apples. What does y stand for?
Numbers of pounds of bananas.
Bananas. You have to understand that. There's no way you can put this into an equation unless you can pull that out of the equation. X stands for apples, y stands for bananas. The equation should start looking different to you. What I need you to do now is write your equation 2 times. Why would you write it 2 times?
X-intercept and Y-intercept.
X-intercept and Y-intercept, but now the X-intercept has a category. So we'll see if we can put it into a sentence. 1.5x plus 0.6y equals 6. All right. Now, on the first one, if I'm solving for x, what do I plug in for y? 0. Go ahead and solve for x. But then I'm going to need you to put it into a sentence, what that answer means. Okay, so to solve for x, I plug in 0 for y. 1.5x plus 0.6 times 0. Anything times 0 is what, guys? That's gone, okay? So now, what do I divide by to solve for x? 1.5. Divide by 1.5. What is 6 divided by 1.5? X equals 4. Okay? I'm going to give you a chance before I tell you what does this mean. Go back and look at what x stands for. Micah?
If I buy 1.5 pounds of apples, it would be $4.
No, but I like, you're on the right track. Mason?
If
Let me start it. I can buy 4 pounds of what? Apples, because X stands for apples. Okay? Of apples. Now look at this. If I buy how many pounds of bananas?
1.
0.
0.
Because you plugged in 0 for Y. Didn't Y stand for bananas?
Yes.
I can buy 4 pounds of apples if I buy 0 pounds of bananas. Okay? Remember at the beginning of this, I said this is going to be all or nothing? Okay? So that's what's happening here. Okay? When it says in the question to use intercepts, that means right there it's an all or nothing scenario. If I'm using intercepts, then one of my values is 0. When 1 is 0, meaning I buy no bananas. I hate bananas for whatever reason. I like bananas. I mean, they're good.
I love
Okay?
bananas.
Then I can buy 4 pounds of apples. So guess what? If I bought 2 pounds of apples, I have some money left over. I could buy bananas. All right? So now that you've seen X, I want you to do Y. Find your Y-intercept. Do the second one now.
Wait, do you do
Find your Y-intercept and interpret.
Do you do 0.6?
All right, guys. Did we plug in 0 for X? 0 for X, so that's gone. Now I divide both sides by what? 0.6.
Apples.
So Y equals what?
3.6. 10.
10. 6 divided by 0.6. Okay, so now someone put that into a statement for me. Anybody put that into a statement? Josh?
I can buy 10 pounds of bananas if I buy 0.
Perfect. I can buy, and I'm not going to write it down, but the words will be on your video, and you guys could write it down if you want. I can buy 10 pounds of bananas. Y stands for bananas. If I buy 0 apples, which is what I plugged in for X. So do you see, guys, how X and Y now, they actually mean something to me. As soon as I give it a value, it's like, oh, well, X stands for apples. Okay? I'm going to ask you for one more interpretation. It's not part of the problem. Look up here for a sec. Look at the original equation. 1.5. Can anybody tell me what 1.5 would mean?
1 and 1/2.
Okay. 1.5 is my rate of how much I would pay per apple. So 1.5 stands for what in dollars?
A pound.
$1.50 per pound.
Oh,
Watch this. Watch this now. Go back to your X value. If you can make this connection, this is kind of like a light bulb moment. X equals 4, right? So if I plug in 4, that means at $1.50 per pound times 4 pounds, guess what that's going to equal? $6.
That's wrong.
$6. You see that? Okay. So now go over here to the bananas. You said 10 pounds of bananas. So look here. How much is it per pound?
60 cents.
60 cents. So think about it in dollars. 60 cents times 10 is $6.
Our bananas less than
So you spent all your money, all $6 on 10 pounds of bananas. Well, where I see a lot of bananas is at like a race, like a 5K. Usually they'll have like a lot of bananas. Why? Because they help with cramping.
potassium.
Yep, potassium, exactly. Okay, so we'll see 10 pounds of bananas plus just a huge like table of bananas. I don't know if y'all have those at cross-country meets, but a lot of times they'll be there. Okay, but do you see that, guys? Do you see how it really makes sense? And now the 0.6y makes sense too. 60 cents per pound. All right, that's everything you need to know for 4.5.
I get it.